Hello. On behalf of the iCity team, welcome to our iCity Research Days webinar series, and thank you for joining us. I'm Dr. Judy Farvolden, Executive Director for the Transportation Research Institute at the University of Toronto, and your host for the iCity webinar series. Just a couple of housekeeping notes. This session is being recorded, as are all of the sessions in the iCity series, and the recordings will be shared. We will have a Q&A following both talks. Chat has been disabled, so please use Q&A to post your questions. iCity Urban Informatics for Sustainable Metropolitan Growth is headed by Principal Investigator, Professor Eric Miller, and I am iCity's Project Manager. iCity is a highly interdisciplinary collaboration among researchers at 3 universities, the University of Toronto, OCAD University, and the University of Waterloo. We are grateful for the support of our public sector partners, Waterfront Toronto, Transportation Services at the City of Toronto, and the region of Waterloo, and that of our private sector partners, Esri Canada, IBM Canada, and Celent. We could not have done it without their support, both financial and in many forms of co-creating and collaborating. iCity is funded by the Ontario Research Fund, Research Excellence Round 7, and we are grateful also for ORAF's support of our unique project. Over its 5 years of collaboration, iCity has involved 108 researchers working on 9 projects organized in 3 themes and produced 94 publications and counting. iCity is founded on 3 themes. Theme 1 provides a foundation of ontologies and platforms, the subject of last Monday's talks. Theme 2 comprises a set of urban transportation applications in street design, parking, transit-oriented design, and integrated transportation and land use planning. These applications are activated by visualization and decision support tools created by our fine partners at OCAD University. You will hear from a couple of them today. This is the second in a series of presentations. I hope you will join us for others in this series. You can find details and register on the U3 website. As I said, Theme 3 visualization and tools activate the urban transportation applications developed in Theme 2. Support of Theme 2 applications were among the key deliverables of the OCAD University team. We'll see more of that in upcoming seminars. Today, our speakers will present early results and visualization contributions. I'll briefly introduce them to you, but you can find out more about them on the information posted on this series on the U3 website. Today's speakers are Dr. Sara Diamond and Professor Jeremy Bowes of OCAD University. And their first talk is Understanding Urban Planning and Transportation Visualization Needs, Compara and Vizland. Jeremy Bowes teaches an environmental design program and the Strategic Foresight and Innovation graduate program. His research centers around sustainable living design approaches for habitat dwellings, building on past architectural housing experience and a systems design background. Jeremy co-led iCity projects in visualization and decision support with Dr. Sara Diamond. Sara Diamond is the president of OCAD University, Canada's University of the Imagination. While retaining OCAD University traditional strengths in art and design, she has guided the university to become a leader in digital media, design research, and curriculum, and has built strong partnerships for OCAD University with science and business communities in Ontario and abroad. As a leader of iCity's Theme 3 projects, Sara has focused the talent of OCAD University on co-creating exciting new visualization capabilities for transportation applications. She steps down from the presidency of OCAD University on June 30th. While she'll be missed there, we plan to fill her time with further collaboration and discovery. Jeremy will be presenting the first talk, with Sara providing an assist in the Q&A. Over to you, Jeremy. I'm going to pass the screen to you now.
Thanks, Judy. Today I get to talk to you a little bit on comparative methodology in Compara and Vizland, which was the development of applications looking at urban planning and transportation visualization needs. And at iCity, we're developing these decision support tools. And part of this is defining a taxonomy of visualizations to assist visualization systems designers in understanding key visualization techniques that serve multiple groups. The challenge for us, in many cases, was to ensure that the challenge is to ensure diverse groups of users have appropriate levels of accessibility. And so we began our research in comparative methodology with a series of expert interviews, literature review, and a comparative methodology in urban transportation software applications. What this gave us was software application categories, and we looked at user stories, transportation, urban design, data analysis, land use, entertainment, mapping, infrastructure management, and we did a scan of many different software applications and the users and their kind of domain. What this allowed us to have was a taxonomy that was really a capturing of essential aspects of visualization that centered around users, tasks, and data type, and really the use domains that were incorporated in this. And what became really important was user task, the level of interaction or engagement, and data type. And as we moved forward, this work, why is my screen not working? There, oh man. I wanted to show you a comparative methodology chart that we prepared of all the software. It's something like 30 pages long, but here's the list of kind of top categories that we have. And really they cover software, technology, platform, description, the user type, tasks, the engagement level. And what we did is a scan of something like 200 different software packages. I'm not sure what's going on with my computer, but anyway. This helped us in really aggregating user types, use domains, user tasks, and the type of data being used for urban transportation. This research approach and process really provided a couple things for our next exploration, which was really a use case survey, use case mapping, and a design charrette to do some priority identification and mapping of users, tasks, and data. And this is a diagram showing some of the users and some of the programs and applications, and then some of the data that is required. We also did a use case survey, and we centered around sending this to most of the group members, and we got lots of feedback around the conditions and their technology usage, the assets that they required, task interaction, the kind of data visualization. And we also did a little design charrette. We followed this up with a design charrette in June of, I think, 2018. And we learned a lot in that around how to build interface prototypes. So in the end, what we did to materialize this is we developed a kind of user-centered taxonomy for urban transport applications. And we developed a low fidelity prototype. So this is basically it's a sheet that we can check off and fill in, and it covers users, use domains, the context for engagement, the data type, and the kind of interactive controls and visualizations that particular users are doing. This, here's an example of a use case, an architectural technician who's involved in urban design. And so they're using geospatial data, and they're looking at graphic frameworks, and they're making use of abstract and spatial data. So when you look at the whole sheet, you can see there's user engagement goals, there's visualization components, and we circle all of the different levels of user, the context, the level of engagement, whether they're synthesizing and analyzing or authoring, the kind of interactive controls they require, the kind of use of charts, graphs, networks as a representation intent. What this gave us was a kind of low fidelity model for a prototype. So at this first stage of literature review and really low fidelity prototyping, we identified a variety of approaches to the complexity of visualization required relevant to task levels and interactions. This provided an understanding of the ways that taxonomy could actually be used by our researchers in the field of visual analytics. And it highlighted the need for visual libraries and a way of comparing user needs around tasks and levels of interaction. The next stage for us was really to implement this, and this talk really is about the comparative methodology and carrying it into user tools. So we did the application of this taxonomy into producing some 3D modeling and dashboards for specific users, which you'll see in other presentations. But one of the thing that really came out of this was the prototyping of comparative methodology as a series of applications, and the role that this research played to contribute to cataloging and mobilization of common visual analytics. And comparative tool sets we used as the driving force for these prototypes. So Compara was really an application that was developed, and Marcus Gordon, one of our researchers in our visual analytics lab, really kind of spearheaded this and provided a semi-interactive explorative view of the comparative toolset list that Manpreet, Janeda, and myself had compiled. And before we go into how we did it, I just wanted to say that really there was an aspect of this that was really important, which was really to create a query tool to search keywords and visualization types. And we thought that that would be a great support for the fellow members of the iCity team. How this started was really mapping relationships, and the beginning of this, and using a program like SimpleMind, and there was a few others, was to really look at the relationships between tasks and users and domains, and in terms of making an intent about what the clusters of different groups and factors was. So for instance, this created an effort to create a Compara overview. And so this is just a rough sketch, but you can see, and it's, I know you can't read it, but all those clusters are things like tasks and users, etc. And I'll show you that in a minute. Our approach really revolved around this mind map as a visual language of choice. And the process that we took through was to take the master list and translate it into a hierarchical software taxonomy showing the attributes. And so this spreadsheet was really the start of this kind of taxonomy, and it consisted of 8 main categories of content groups. And the list was, sorry, things growing faster than me. The list was really all the lists that we had done in the comparative chart, and it was divided into buckets of groups and user groups and applications and domains, and such as toolset, name, owner, manufacturer, technology platform, etc. And the crop section shows us beginning to translate this into a kind of software application of tasks, user types, interactions. And in all of these cases, we wanted the tool to have the functionality of selection so that users could in fact select various aspects and make it their own in terms of their choice. So some of the technology and file types we thought were really important, because in the end, one of the things we really had to do was to be able to accommodate many different file types and many different users and many different technology platforms. What this did for us, and the toolset map really helped, was place these in focus in terms of seeking a slightly more improved way to navigate the data. And the mind map really helped in that sense, that we, as a group in the Visual Analytics Lab, could kind of look at the clustering of things and decide how they would be translated through D3 into a kind of software application that would support a number of groups. This was all driven by the comparative master list, but as a method, and our the first prototype that David Sitzeng and Michael Carnival and Marcus Gordon created was a prototype based on the little diagram below, which was really a translation of converting CSV to JSON files and D3 tree data into this bipartite example shown above in the diagram here, which really maps different aspects of tasks or users against software. So this was the beginning of the first prototype, and it went through a number of iterations, but the interaction here shows the various connections and tools. So if I go to the next slide, you can that at the idea in your upper right hand corner, you select by user or you select by task, and what Compara would do would be to actually draw connections to software or groups of software, whether they're public or private or open source, within the domains that those software applications seem to exist. You could also do it by task, and for instance, this is also showing now in the next little bit, it'll show the relationship of picking a task that you might want to do, like presentation or visualization or communication or consultation or operations, and selecting and highlighting different tools that might support that kind of activity. So these kinds of selections, and we wanted to make it even more extensive, but as a prototype, this is where we started to try and create a model that kind of summarized, the research that we had done in the comparative methodology chart. What this gave us was really, and the next stage for Compara was really to take this into a website platform. Now, one of the things that was really missing in this, and this is just a preliminary idea of what a website might look like with it loaded, so that you could see relationships and hierarchy and focus on specific software groups, et cetera, and you could actually do your own kind of user type or tasks to analyze that. So that's the direction we were going. There was a missing piece though, and I want to talk about a second application, which was really Vizland. And Vizland was really based on a visual library provided by Silvestro, Silvero Rebecca, and I'm just showing this to you now, but I just wanted to go back because really we had some 60 plus data visualizations that we actually included. And the idea was to give the user information about how each one could be used and what its application was. And it was necessary then to coordinate this with Compara. So the Vizland application in itself really is an active application where you can mouse through a series of applications, which is what this is doing now, and it tells you a little bit about that particular visualization, what its applications are, what it's called, et cetera, and gives you an example. So we did that and for a number of visualizations, and we related this back to some of the Compara. The mind map in behind is really showing you how Marcus and his team related it to some of the work that was being done in Compara around visualizations that suited specific tasks. And if you highlighted, and I'm not sure you can see that on the screen, but in the upper right hand corner, as you do a search, for instance, if you type in pattern, this application will highlight the key kind of, whether it's a bubble chart or dot diagram, it will highlight the kind of, or a heat map in this case, will highlight something that is applicable to the visualization of that particular data that you want to visualize. So the idea of introducing a query keyword associated with these visualizations was to give quick access and prominent kind of selected visualizations for prominent visualizations. Where this brought us to in the visualization landscape was the idea of, this is something we're still working on, was the ability to query keywords associated with these visualizations. And what this sets up in a way, and I'll just skip to the next slide, I'll take you through some of the steps of this. We located a source, which was Silvero Rebecca's visual library, and we integrated that as a visualization catalog. The data set was, and we only had 60 definitions at first, and they were all manually input. But the idea was to visualize with a method that anyone could see and read, that was quick enough to absorb, so our users could actually access it themselves and decide which ones could work for them. So as a template, this is kind of the field, and in the upper right hand corner, you would actually check which patterns and what would come up would be the highlighting of key kind of things that would be suitable to your use. And with that, for instance, here's the definition that I was showing, where a dot map would tell you a little bit about what it was for. As an example of this query made for traffic management, and this was during the charrette that we ran, if you typed in something like pattern, for instance, for traffic management, it might, the Vizland might provide a relationship or a correlation between pattern, spatial, and show you different kinds of maps, like connection maps, which were great for showing relationships geographically, or dot maps. And the same is true if it related pattern and flow. So you could type a few different things in. So Sankey diagram might be one that you use to show qualities in proportion to one another, or parallel sets, or a stream graph. So those were all kind of selections that, based on that kind of came out. So our next steps were really to isolate this prototype limitation, looking at Compara and Vizland and how they might integrate. And so with Vizland, it was really determining and doing a web version. And Marcus Gordon, although he's published with Sara on this particular development of this, the next stage is to kind of take it to a web application. So Project Compara and Vizland really together would be the idea of providing the tool set in a dashboard that would allow users to both map their functions and integrate their domains so that they could actually have suggestions made in terms of visualization. And that's what really this is showing is Compara derives its intelligence on tool sets and software and user group and domain specifications tasks. Vizland provides the optimum representation techniques most suited for a particular use case. So summarizing, this Compara and Vizland were really part of our taxonomy focus development. And in addition to understanding that user tasks and level of interaction, engagement, and data type were kind of key, we tested these against many kind of spatial and non-spatial data types that our research groups would need. The taxonomy prototype provided an outline or a key framework to access these user visualization needs and to provide a framework for them. Compara and Vizland were created as a series of interactive tools to be plugged into a dashboard to provide the integration of these functional user elements, and so that users would actually get some kind of visualization support in terms of selecting their own kind of visuals. So thank you. I hope that I used my time well, and that's the end of my presentation. Thank you for listening.
Thank you, Jeremy, and welcome, Sara. We have time for a couple of questions. Let me, I'm just thinking through the own experience that I had in this project. And one of the features of iCity is its multidisciplinarity or interdisciplinarity or whatever we call it now. And we found, especially in the early days, that people out of different fields speak different languages. So can you tell us maybe what you learned about the differences and similarities? You developed these useful tools, the difference and similarities of the kinds of tools and what the different users with different needs have of these tools. And we can think, in our own case of engineers and planners and designers.
Can I just kick in a little bit, because I was there sort of at the very start off of this, and then I'll hand over to Jeremy. So I think it's interesting because there's a history in the field of visualization, a very deep history of an argument between generic tools and specific user domain tools, and that challenge is ongoing, by the way, now as AI and machine learning and visualization are merging more and more, partly because of the sorts of differences within data sets that different domains need to use and the different kinds of outcomes that they need to be able to undertake and the different visual languages that they speak. So I don't think that debate is resolved yet. I think the strength of what we tried to do was to understand, as Jeremy's outlined, I think, very clearly, the ways that different kinds of user groups might use even the same tool set in different ways with different kinds of tasks, where there was an overlap of tools, and frankly, where there was a gap in terms of the kinds of tools necessary. One of the maxims of visualization, going back to very early days, people like Ben Schneiderman, who's one of the, really philosophers of visualization, is that it's really important to show multiple ways of representing the data, even the same data set, partly because different kinds of users have different perceptual capacities and different ways of interpreting, and also to show that the same data can be understood in somewhat different ways. So, I think those are underlying pieces that when we built the taxonomy framework, and working with Jeremy and Michael and Marcus, who are really drivers of a lot of this work, and Manfred and Frida as well. It was those sorts of principles, I think, that drove it. So Jeremy, over to you.
Yeah, I just wanted to add that that was probably the biggest challenge of this project, in the sense that for us it was a delightful experience of learning about many different disciplines, and we were amazed to find that every different discipline had its own terminology, its own approach, its own tools, and that was both enlightening but also terrifying, because what we realized very early on in some ways is we had taken on a task that was really complex, in the sense that we had said, oh, we're going to produce a tool that would be good for everyone. We just didn't understand at the time that everyone was already using a different tool. And so in a way, part of the work that we did, and that's why Compara and Vizland became so important, and the earlier taxonomy work, was to try and establish some kind of process that would work for everyone, so that we could actually bring everyone together as a team, rather than everyone being talking their different languages. And you really notice that when we got into the programming of Compara and its graphic interface with D3, that we really had to spend hours sorting out the terminology and what each one meant, and whether that was going to work for all the different users.
I have an observation and maybe one more quick question. There may not be a short answer, because you talk about something being useful for everyone, and planners talk about there being many publics. So yeah. How do we, it's not one size fits all, how do we? I guess we have more work to do.
So maybe I'll jump in first. Is that's actually one of the dilemmas, I think, that goes way beyond this project and into our society in general, is the idea that, no one wants one size fits all, because in fact, the axiom is that it fits no one then. But the other part of that is that if we all have different tools with different languages, it makes communication really difficult. So somewhere in the middle is a territory that we need to establish. And I think when Sara talks about the dialogue still ongoing, that's the dialogue that hasn't really been really sorted out yet, is where is that middle ground where we have our own autonomy as a domain, but at the same time, we have the language that we can share with others.
Well, there's this concept of data fluency too that's very important, which is, that different levels of users in different communities need to be able to understand and analyze and frankly critique data, and have the tools even to add their own data. So I really don't believe that one size fits all. I think what's necessary is, a set of translational tools that allow the same data set and different maybe levels of sophistication of visualizations to be translated into more accessible representations at points in time, more graphically engaging representations, more beautiful representations. Sometimes you need to use metaphor when you're showing graphs and interactive design. So I think that we need a range of ways of representing the same data sets, and as I said before, representing the same data using different kind of methods. Like it can be a circle graph, it can be a linear graph, so that we really build that fluency and also allow communities to see their own data and to be able to understand it and challenge assumptions that are being made through planning and engineering processes, as well as contribute to those.
It may be that the contribution to visualization that every domain makes and has to share becomes kind of, visualization itself becomes a kind of language that crosses many of the different disciplines and integrates them. It's, especially as we go into increased AI kind of operations, you start to see that there needs to be a standard, because the public and all the different publics need to actually see that and understand it. So that becomes the need for common ground.
And many of us are baffled by data. Okay, well, we have to leave that one there, but we're not leaving you, so we get a chance to come back around to this. I want to say that, you know, these are very short talks. We wanted to keep it short and tight because we know everybody's busy and zoomed out, and yet we're so excited to share the results of our 5 years of collaboration. So the results of iCity's Theme 3 work in visual analytics, GraphTrails and story facets, which we'll hear about next, are posted on our brand new iCity website. I hope you'll visit the website for more information on the people, publications, and presentations that resulted from this work. You'd find information about all the iCity projects here. And back to our speakers. Okay, and we're at presentation number 2. And we've introduced them, so we'll just keep going. This talk is 2D and 3D tools for urban analytics, Betaville and GraphTrails, a case study. In this case, Sara will lead the presentation and Jeremy will assist in the Q&A. So I am going to stop sharing and pass this over to Sara. Sara.
Great. Thanks so much, Judy, and very excited about sharing. This is a bit of a case study that gives you a sense of some of the pre-work around data visualization that we undertook, and then actually informed a taxonomy. So it's actually super to be able to show these two things together. Hopefully I'm not showing that, but I'm showing this. So I'm going to talk today about work that we've done, with transportation data. And this is very early work. This is 2015, 2016, with a large group of researchers. Cody Dunn at the time was working with IBM and developing a very interesting set of tools, which I'm going to share with you. And Jeremy joined us a little bit later, and Carl Skelton, who was the postdoc at the time, Davidson Minsheng Yang, Michael Carnival, who you've heard about earlier, Martin Kaplan, who's a German researcher who we were working with, and I'll talk about this, Jiwon Kim, Nanini Lee Balki, and Marcus Gordon. So quite a big team. And very fundamental to this research are a set of questions that do plague visual analytics and continue to, which is how to really understand when it's appropriate to use one-dimensional representations, like a simple graph, two-dimensional representations, histogram, for example, and then 3D representations. 2D representations place data in context, and cartography, which really is about looking at mapping with some great thinking by Nusrat. Describing cartograms is really a means to interpret data that's encoded in mapping, understanding cardinality, for example, the kinds of tasks that users undertake, and where does the task operate within the data, which is just a great way of thinking about drilling down through that representation into the data sort below. 3D volumetric visualization, which often uses multivariant data and has to be used with great care. Sheila Carpendale, who's one of the research mavens of visual analytics globally, but in Canada, talks a lot about how there's been a kind of flirtation with 3D representations, but they often actually lose the user who can't easily understand and interpret them. And then, as I said before in our previous presentation, that multiple visualization strategies allow different qualities of the data to be interpreted and to make comparative inferences. Transportation data is spatial, it's temporal. To quote Ma and Chen, these data are highly and they have wide coverage, they're comprehensive. So there's a complexity to this data that's particularly maybe meaningful. The question of how to map demographic and survey data over route data, looking at things like availability and cost, how do you interlace these kinds of representations, was a very big question for us, from the beginning. And the need to address the kind of goals, means, and characteristics of cardinality. So I talked a little bit about this, and we had a really wonderful project, and I'll talk at a bit of length in a short time about what that project was and then how we interpreted that through different kinds of ways of looking forward. So we'll start with story facets. This was just a kind of screen capture from story facets. It is a software system that Cody Dunn was developing, which allows for the visual exploration and presentation for relational data. He had been working on GraphTrails, which is a more kind of simplistic piece of this, which allowed a user, an analyst, to look at the history of their discovery path within visualization, within the data. Extremely important piece of research, which was integrated into Story Facets. The idea that you'd have one source, multimedia environment to explore complex data, and to, as I said, to look at the provenance of that data, and also your path through it, partly to debate with other analysts about how you came to conclusions. So collaboration-minded and communication-centric, and suited for transportation planning. And within an analysis session, to be able to have multiple views of a data set. And within the iCity collaboration, we worked to be able to, and we built CSV file importing. So, you know, our goals were to enhance the quality and the performance of the web-based visualization prototype, and to add additional features, and to undertake storytelling more effectively, and maybe just to reinforce, you know, that data visualization is a lot about being able to tell effective stories with data. We wanted to make sure that there was effective data collection and loading, application performance, the ability to have annotation when you explored a trail. So when you went back, both making your trail through data, and then when you went back, you understood why you made those decisions. So that's context one, and we'll come back to it. And then, you know, part of, as I said, Theme 3's goals were also to look at three-dimensional cartographic and time-based representations. And so we were working with Betaville, which is an open source software environment that was provided for us by Carl, our research postdoc. And it managed GIS, information systems, data collection, data preparation and importation, as well as visualization. And its goals really were to recognize there was an open source environment, so using standard GIS tools with plug-in capability to manage spatial data, its attributes and coordinate systems. But also, it was a little bit of a competition with our colleagues at Esri Canada, and we work very closely with them now, maybe more than we did in the beginning. And they really did have, but in a proprietary environment, the gold standard for GIS cartographic representation. So we also, in the work with Betaville, wanted to be able to combine with ArcGIS and the Esri platform, and we did some interesting work there. So just to give you sort of a small tour, I guess, through Betaville. So, you know, it is an analytic system that allows the user to be able to query and then build cartographic, fairly accurate graphic representations of specific environments, and then to be able to move through those. Carl Skelton's ideal, and he was working with his partners in Germany at Brennan University, who remain partners for our university, was, as I said, the potential for an open source software architecture to support broadly based collaborative participation. And picking up on Jeremy's presentation and the conversation afterwards, you know, really looking at this question of democratic engagement with architects, with city planners, with transportation engineers and planners. So to be able to synthesize quantitative and qualitative information and decision support. And as I said, over time, we built some interesting extensions for Esri software with Betaville. So again, this is in the US, but this is giving you the idea of how in the New York environment, Betaville was used to imagine and plan different versions of the Liberty Piers. And again, just some of those kind of representations. And then in a very sort of crude way to give you, and this is the ways that in our case study we began to use Betaville to really look at how to think through, in this instance, 3 universities that we analyzed with Student Youth Toronto, and I'm going to talk about that in a moment. So to locate them on a map, and then to kind of look at the density of student populations within a survey environment, and to show within that map the sources that students were coming from to those environments. And then you can see, so this is 2D, and this is idea of a 3D volumetric representation. And the idea here is that once you move into a 3D environment, you actually, get a sense of the density of those student populations in relationship to those institutions. So you can see how 2D and 3D, play a very different kind of interpretive role. Some of the work that we did in sort of pre-tests with Betaville are working with the Toronto Open Data Repository, with statistics and spatial data, and kind of using those as sources. And then to build out and test these sorts of representations where you have just a basic grid, and then you can add a component of student population in this instance, and then add concentrations and densities of that student population. And we ran a series of tests, within Betaville, and also kind of comparative testing with ArcGIS and City Engine from Esri that can show different kinds of quantities of density within components of the GTA, and just to look at how 3D visualization, can really work effectively in a volumetric way. So, and you get the kind of God's eye view here. Part of what Betaville was trying to do was to give you a pedestrian point of view as well as this sort of aerial point of view moving forward. So moving then into the case study, and just trying to make sure I didn't left anything out. Yeah, so a wonderful case study. There's a terrific collaboration which is ongoing between the 4 presidents of the GTA universities. So it's UT, OCAD University, Ryerson, and York. We look at phenomenal challenges, and there's many with COVID-19, and we're continuing to talk and collaborate a lot in our current environment. So we look at phenomenal challenges, tough questions, wicked problems, a designer would say, that face our populations. And one of the first challenges we took on was, how do students access our universities using transit and transportation? We were watching escalating costs, lack of available public transit, huge concerns on the part of students about affordability, and ways that we thought mobility was affecting student success. And we really wanted to undertake a study together that would look at that. So we threw that question out to our research teams, and a team was formed. I got to play 2 roles, one as president, helping to fund this, and the other as one of the researchers as part of a larger team that was looking at exploring Student Youth Toronto data. So this project undertook a really, really massive survey where we reached out to students, and there were 184,000 students within the GTA at our 4 universities. We got an 8.3% response rate. So about 15,200 respondents who kept a diary. So over 36,000 trips of a single day travel journal, one of the larger, if not largest, aggregations of data of the student population in terms of how they travel ever undertaken in North America. And they provided information on how they live, they work, how they travel, through their day, and how they schedule their studies and their daily activities. So this was really important research. The goal was to support infrastructure and programs to support student travel and student travelers. And we found that 33% of respondents spent 2 hours or more a day traveling to and from campuses. And you can see the ways that infographics were developed by the design team to just give you the sense of different kinds of transportation modes that students were using to the different campuses and the time spent in one-way travel. We used postal code region data and university destination to code the data. And you could see, some of the priority areas as well, within the City of Toronto. So interesting, and this wasn't part of our research, but you could do a very interesting correlation around areas where there's more poverty and challenges and lack of services in relationship to where students are positioned. And just giving you a sense of, again, visualizations of postal code shapefile and QGIS data. And then to begin to give you a sense of where the universities are located, and just the relative density of U of T students living in each postal code, for example. So different kinds of visualization strategies that were used, and this is using Betaville to do some of the basic representations here to understand some of our questions. So we wanted to look at the cost of housing, the impact of parental decisions. Very interesting, for example, in the OCAD data, students are OCAD students travel the furthest, probably not surprising, or highly specialized students choose to come to the university because of that. So some travel 2 to 3 hours, one-way trip to get to our campuses. But factors, so cost of housing, parental decision making, the ability to walk or bike, housing quality, and proximity to transit. And here you go, there's that back there. So we used both of these two systems. We used Betaville, and we looked at the infographics, right? And we said, let's use our two emerging software environments and look at the data and represent it in different ways. And let's look at things like time to commute and commute distance, and we wanted to understand the impacts of going to school. So I'll show you just some of the images coming out of this. I'm not showing video. I thought it was simpler to just sort of show some of the representations in Betaville, but what we've done there essentially is used a God's eye kind of 3D graphic environment to be able to look at the time mode from OCAD, this is OCAD data, so solo driver, walking, etc. And then the proximity, so the length of the bar going up shows you the numbers, and you can see the distance and the time spent within that travel. And again, some other perspectives here on the OCAD data. This is Ryerson data. Ryerson students tend to be much closer to their campus. U of T students have 3 campuses and they're close there, and York students are further away from their campus. So we represented in Betaville and also looking at frequency of trips to campus. So different kinds of things that we were able to show. This is more of a sort of from the ground perspective. And then we undertook the visualizations within story facets. So our goal here was to be able to build a kind of integrated environment eventually, which I'll show you at the very far end. And you can see here how this is, for example, story data on a student response to a card that would provide some better support for student travel. We were able to import existing explorations. This is about bikes and the use of bikes into story facets, so you can get comparative data of the age of users. And this is, again, looking at if there's a new shuttle, would students be willing to use that shuttle? So you're seeing here how essentially story facets provides mostly 2-dimensional and 3-dimensional graphs. This is looking at the age of our respondents. We had a lot of demographic data and their commute time, their income and their commute time. And then this is the ability, as I said, to import a CSV file into story facets. So this was a sort of proof of concept. And to then look at different data types and to run essentially the single household, for example, to run that analysis and then to arrive, with a visualization eventually from that process. So my time is going to run out. So then what we did was we were able to integrate, which was the exciting piece, this sort of 3-dimensional environment and put it together with the 2-dimensional representations. And then you have a presentation context, because remember, this is really about building a storytelling platform where you can see your analytic trails. You can look at the decisions and analysis that you've made. This project's a very important project. It's continuing with a large partnership grant from the Social Science Humanities Research Council. Jeremy is the lead researcher for OCAD on that, and I'm a collaborating researcher. And it's very exciting. We're gathering massive amount of data. Again, looking at mobility tools, personal attributes of students, household attributes, large-scale travel diaries. We've got a larger group of institutions, including colleges, designing what the visualization will be. So we're bringing all the work on taxonomy, all the pre-work on a sort of 2D, 3D, and 4D, which is time-based analytics environment, looking at how to build essentially, an effective dashboard to look at this work. And these are just, again, looking at examples of visualization types, recalling Vizland, ways of thinking about household attributes, and then building, these are sketches for a dashboard environment. And this actually draws from work that we're doing on a number of other projects, including iCity and an electric bus project. So I guess, if I look back on it, we did move from Betaville into working collaboratively with Esri. Esri built more and more tools that were allowing collaboration between different kinds of groups and sort of 2D graphs as well as 3D representation, and the ability to run complex queries and different points of view. So we're working closely with them. So we're less engaged with Betaville. And in terms of the kind of story facets work, Corey moved on to University of Northeastern University in Boston. And a lot of the learnings from that work has really informed our dashboard work as we move forward. So I'm going to end there and stop sharing my screen and open for questions and conversation. Thank you.
Thank you, Sara. Welcome back, Jeremy. We have time for a couple of questions for Sara and Jeremy, and I did have one from the audience. We talked about many different people and their needs, kinds of people and their needs for different kinds of visualizations. How do we make visualizations accessible to people with some kind of visual impairment?
I'd love to answer that. That's a great question. This is also the Visual Analytics Lab, maybe ironically because it's called Visual Analytics, has a number of different researchers associated with it, and Peter Kopin is one of our research partners. We also have the Inclusive Design Research Center at OCAD, and we're really engaging with sonic representations of data. I built a system with Dr. Anna Joffre, who's a postdoc at OCAD, for haptic representations of data and being able to actually move objects around to create representations of data that can be interpreted visually or sonic in sonic means through graphs. So I think this is a really exciting area, both for people who do have visual impairment, but also, frankly, to teach about data using a multimodal sensory environment. And I think as artists and designers, we can bring those skills to the table.
I'm glad we had that question, and I'm glad that there's such a great answer for it. Right. And so we talked in the last round of questions, we talked about using visualization tools for many kinds of people, and urban planning is generally like a process of engagement and consultation. And you've been working in data and visualizations. So how do you see that, what is the benefit of data software visualizations for effective planning?
I think it's huge. I think we've already been working with Waterfront Toronto and hope to continue that relationship. This is, iCity and OCAD in some other ways, and with Esri Canada to Michael Carnival built out with Esri Canada one of the great, really beautiful, 3D environments of the waterfront. And it's exactly what people need to be able to do scenario work to say, if I do this, then the implications are that. If I do this, then these are the implications. And you're going to see complete streets. And I encourage people to, watch that, because we did a lot of work with our colleagues at U of T to build a tool for a dashboard for exactly that kind of trade-off planning. I think making those tools easy to use, really important.
And, and certainly those of us who work that way know that that's a challenge. None of these complex things are easy to use right now. So usability, I know that's another, user experience, another one of OCAD's strengths. Only quickly, I understand what it was like from our side of the fence at University of Toronto in engineering to work with OCAD University. Just quickly, what was it like being you?
Maybe I'll say something and then Jeremy. I mean, I'm weird because I have a computer science doctoral degree. So I kind of have two sides of my brain. But I think that processes are different. I mean, we have a whole use case idea and kind of iterative design and engineering and fast prototyping. And I think making sure that we have our world parallel the worlds, I think was a bit of a challenge, but I think we got it down once we started to build real stuff. It immediately became easier. And that's the strength of artist designers bring, is that we like to build stuff. Jeremy.
Well, I would just add that, you have to remember in many ways that the research that many of the users that we experienced at U of T and other institutions are doing is very deep. And a lot of it has deep rationales about what it's for, but it's not necessarily, the visualizations really help to get the message to people. And decision support is everything, right? Like when you, especially working with the City of Toronto and seeing some of the struggles that some of the groups had in traffic and transit with the City of Toronto and trying to communicate the ideas that they had for how to make the transit system better, was really interesting to see that the stumbling block was quite often just getting the ideas across visually, especially when they were supported by data. Like a lot of the researchers had data, and there it was. We needed to get it to the respective decision makers so that they could say, yeah, no, this is a better way, right? And we experienced that both in Student Move and also with Sidewalk Labs and the waterfront in terms of decision-making support. Like the visualization of the data is really important.
So we talk about evidence and supportive decision-making, and maybe we'll also have storytelling and supportive decision-making. So again, let me say that thank you very much, both of you. These were very short talks summarizing 5 years of excellent research. So let me remind you that you can find out more on the iCity website and encourage you to go there and find out more about the projects in Theme 3 and others we'll be talking about. I hope you enjoyed today's presentation, and I hope you'll join us for other presentations in the iCity series. Next up is Foundations for Planning and Operations. We'll have 3 talks of 30 minutes each on geosemantics exchange, also known as making use of ontologies, visualization of origin destination model outputs, and bus bridging visualization dashboard. And then that will be followed by elements of the streets and its users. These 2 sessions are about the theme 2 urban transportation applications that we've been building. Elements of the street will include iCity Park, a study of parking behavior, lessons learned using smartphone data to assess pedestrian behavior, the Complete Streets dashboard, and KidScore, an engagement tool created by our excellent youth outreach partner, Maximum City. We'll finish up with the long view, a longitudinal analysis of urban growth and transportation network expansion, and next steps, a preview of iCity 2.0, urban data science for future urban mobility. The true value of our multidisciplinary academic government industry collaboration will be apparent in the outcomes you will see presented. You can register for all and any of these presentations on the U-Tree website.